Hi again everyone. So in this tutorial video, we'll go through this stats of matter number 2. So this is just another piece of work that you have been set. So it's a mixture of these stats of matter as well as diffusion related kind of questions. So when a gas is compressed, compression of gas means you apply pressure. So you would need to think about what happened to gases when you apply pressure. So if you think about your piston example, for example, I guess if you have a piston like this, and then you apply pressure, so you push the piston even further in, and so you push it further. So what happened then is that here your gas molecules would be like this, but here they are a lot closer together. So what happens in the presence of well, when you increase the pressure on the gaseous particles, they get closer together, and that is very sensible when you think about what happened to gases, right? Because when you increase the pressure, the volume that the gas occupy decreases, and that is your Boyle's law as well, where pressure is inversely proportional to volume at constant temperature. That is your Boyle's law, and as you could see, the volume that the gas occupy decreases in the presence of increased pressure at constant temperature. Next bit, when you heat up a gas, you are supplying heat energy to the gas, and because it's already a gas, the gaseous particles or the gaseous molecules, they're already so far apart, they already have so much energy, and all you're doing when you keep on supplying heat energy is that you give them even more kinetic energy, and therefore they gain more energy, they can move around much faster, but there's not going to be a further change of state because they're already gases. Yeah. It's not to do with compression because that's to do with pressure, and heating is not to do with pressure on the gas, alright? So the gas can expand in the presence of heat when your pressure is constant. That is your Charles law, but it's got nothing to do with that here. It's not losing energy. That's the opposite of what we said was correct, and it's not change of state because it's already a gas, and you heat up the gas further. It doesn't go from gas to something else. Okay, at least not in the more sensible manner. All right. Question 3, a gas with smaller molecules. So smaller molecules could mean size, could mean molecular masses, but something which is smaller would also mean that they have a smaller molecular mass, most likely. All right. And when you have lower molecular mass, that would mean that you diffuse faster because you can travel faster. Okay, so you will diffuse faster than a gas with larger molecule. That is correct. This is not correct. They will not diffuse at the same rate because they clearly have different sizes and therefore different molecular masses. The smaller molecules will not occupy a greater volume because of the smaller size. How can it be bigger volume when it is the smaller size molecule compared to the bigger size molecule? So this is ridiculous, all right? So A is the best option there. Number 4 is to do with factors affecting the rate of diffusion. So you want the diffusers faster, and one of the factors is to do with high temperature. You need to be able to explain that in terms of the kinetic energy. So in terms of the kinetic energy of your particles at higher temperature, how would that affect the amount of kinetic energy your particles would have, and therefore how would that affect how fast they diffuse? All right, so you are also looking at lower molecular masses or smaller sizes, but lower molecular masses is something that we look at. So it's going to be lighter molecule will diffuse faster because they are lighter. All right. So not when the molecules are large, we are looking at a higher temperature, which is to do with this other factor that can affect the rate of diffusion there. Question 5, a substance was removed from a freezer. So a freezer freezes something. So this is a solid there. And then you heat it up, so you supply energy. So you need to supply energy there. And because you're supplying heat energy, that's why the temperature slowly increases, and then here the temperature remain constant because there is the first change of state, and then it goes further because it's already a liquid, and then it become a gas right at this moment, but this is still a mixture of liquid and gases because this is the boiling point, and past the boiling point everything is a gas already. Okay, so from this graph you can tell that the boiling point is equal to 100 degrees Celsius. That's the unit given there. Okay, and then the melting point is 0 degrees Celsius. So reading the instructions, the letter V to Z represent the states of matter. Write the 5 letters. So they are not asking for S or S plus L, L plus G or G. They're asking you to use a specific letter, alright? So starting with V for the solid. I've already given you like lines like this, so I guess we just need to label it. If I use a different color, V, W, W is solid and liquid, and then when it's entirely a liquid is X, and then Y is going to be liquid and gas, and Z is completely a gas. So Z is just that there over there. Explain what is happening, okay, to the particles. So they're not asking you state the process. No, they're asking explain happening particles, all right, at these 5 places. At V, it is entirely a solid, so all the heat energy, so the solid particles just vibrate much faster. The solid particles gain kinetic energy as temperature increases, and vibrates much faster about their fixed position. So because it is still a solid, that's why we're still using the word vibrate rather than movement, because they are still closely packed together. At this stage, when you have both solid and liquid at W, so melting is occurring, because melting is in the process, so it is occurring at that moment. Energy, the heat energy supplied is used to break forces of attraction between the solid particles in order for melting to be completed, alright? So as this is happening, the temperature will remain constant, because for a pure substance, the melting point will be a fixed value. At liquid, when it's already entirely a liquid at X, so the liquid particles gain kinetic energy and can move more randomly. So that since they have more energy, they can move around more randomly and also faster as well, yeah. And then at Y, so you have boiling starts to happen. So boiling is occurring. So heat energy again is used to break forces of attraction between the liquid particles. So you need to separate the liquid particles to make them so far apart, and there is the force of attraction between the particles that you need to overcome, right? And last but not least, you have the gas. So so Z is already a gas. So what happened there is the gas just gain more kinetic energy as temperature further increases. Above the boiling point. There's already a gas, it doesn't turn into something else again, alright? So the substance that was heated was pure. So a pure substance would have a fixed melting point, it will have a fixed boiling point. So we say a pure substance will have a fixed value for the boiling and also melting point. This is a fixed value because it's not a curve or it's not a slope, but it's a one straight line. This is the melting point, it's just 0 degrees Celsius. This is a fixed boiling point, it's 100 degrees Celsius. So both the melting and the boiling points are fixed. Or you can say a pure substance will have a fixed melting and boiling point. All right. So they want you to name the substance that was heated. So previously you saw the melting point was 0 degrees Celsius and the boiling point was 100 degrees Celsius from the graph, as you are expected to read the graph. And based on that information alone, you should know that this actually represent the substance that was heated. Be very careful. This is the tricky bit, all right? So what did you heat? If you read back the original question, you take this substance from the freezer and then you heat it. So what is the substance that you heat? The substance that you heat was the substance that you remove from the freezer. That is minus 20. So you are not heating water. What you heated, the thing that you removed from the freezer, was not water. It was ice, because you took out the solid, not the liquid water. So this is all about reading questions and interpreting information. Yeah, something that you'll be expected to do in a real O-level paper. In this next question, so you have a crystal of these blue copper 2 nitrate crystals. So this is a solid. So this question basically asks you a blue copper 2 nitrate, but it can also be an alternative, which is that purple colored potassium permanganate. In reality, we call it potassium manganate VII. So that is something you will learn in the later topic. So potassium manganate 7. So there is purple. This thing is blue. So both of these, the solids there, if you put a small piece of that solid in the water, they eventually will make the water colored, and the movement of that color, it's not like, because you're not stirring it, it's not uniform, so you get to see how they move randomly, and that is a result of diffusion, okay, in a liquid, right? So diffusion through the liquid, because the particles, the solid particle from this compound, they dissolve into the water, and then they move randomly in all directions. So diffusion is that idea called random motion. All right, so that is diffusion a key criteria. Okay, random motion. I guess I could do a better handwriting than that. Diffusion. So what would you expect to see in the beaker at that point? So what is that point referring to? Until no further change. So that point refers to until no further change. All right, so what will happen is you will have the blue color spread through the liquid, because they dissolve completely, and then they will make the whole thing colored eventually. Okay, because it's until there's no further change, because as the particles move randomly in all directions, even without stirring, eventually all of it will be blue. But of course, initially, as you put them in, the blue color will just slowly turn the solution of the water blue, not in all places being uniform, but eventually, until no further change, this will be what you see. Okay, so as we mentioned earlier, this is a process called diffusion, a definition of which you are expected to master. Is to do with the random motion of particles from a region of high concentration to a region of low concentration. Okay, so we know that it was talking about diffusion, and then they want you to arrange these 4 gases in order of the speed at which they diffuse, fastest to slowest. All right, so looking at the masses, the fastest will be the lightest, meaning to say the smallest molecular mass. So the smallest molecular mass would be H. Actually, these are atom, but in reality what we have is we have N2, which will give us 14 times 2, which is 28, and the same thing go for O2, which is 16 times 2, which is 32, and the same thing goes for hydrogen. So it gets tricky right now, right? Because how do you know the formula? Because you haven't really done formula yet, all right? But the strange thing with neon is that there are single atom. Single atom, that exists a single atom, is also known as monoatomic, simply because it's a noble gas. It doesn't like to form any sort of chemical bond, and this will make more sense once we reach the chemical structure and bonding topic a couple of months from now onwards. All right, so hydrogen is the lightest, so it's actually existing as H2, followed by if you had just looked at the atom, you would have gotten trick, because this is 20, so 20 is the next highest, and not 14 or 16, because they exist as molecule like this. All right, so again, I guess this is a tricky question if you don't know what you are talking about. All right, okay, so basically the atoms, when they exist as gases, they do not exist as single atoms apart from the noble gas. All right, this will make more sense when we restructure and bonding. This is the last question of this assessment worksheet. So this kind of apparatus setup is very popular, especially in a multiple choice question by Cambridge O-level or even IGCSE setting. It's because it's a good way of asking diffusion related kind of question. Okay, so essentially this is a measurement of the equality in pressure due to the gases in here exerting pressure downward, and pressure here due to the pressure from the air exerting downward. Okay, so by right, if you have equalized pressure inside and outside, okay, this will be level. But what happened is that here you see the water level rose on the left side, so this will go up and this will come down. So what happened is that the gas in here must be escaping. Whereas the gas that comes in must be lighter than the nitrogen. If it is heavier than nitrogen, it would have exerted the thing downward, and it would exert more pressure downward, and it would give you this go down and this go up. But we see the opposite trend, meaning to say that if nitrogen diffuse out and gas X diffuse in, gas X must be lighter than nitrogen. Okay, so X must be lighter than nitrogen, which exists as this diatomic molecule. But we have another dilemma, because in another way this question could be asked is, why does it move down? The reason why it moved down could also be because if you have a very, very light gas such as hydrogen, so hydrogen exists as H2, that will give you 1 times 2, which is just 2, and it is indeed the lightest out of the 4 being given here. So CO is carbon monoxide, so I'm just working out the relative molecular mass, something you'll be able to do if you know the formula very, very well, and something that you ought to be able to do a few months from now. Okay, so 12 times 1, because you have 1 carbon atom, and then you have 4 hydrogen atoms, so 4 times 1, they'll give you 16. This is the lightest. If I have hydrogen being there, hydrogen being the lightest would diffuse very quickly. It will go in, and when you have nitrogen still inside and you have additional hydrogen, it will push down. So something which is very light compared to nitrogen, which the MR of would be 17 times 2, which is 34. Okay, as you could use your periodic table, of course. So anything which is much lighter than 34, things like 12 and then 16 is also second lightest, meaning to say they will diffuse pretty quickly into the chamber here, and they will exert greater pressure on top of whatever nitrogen is already present, so it will move down rather than upward here. Okay, so I can cross out hydrogen and CH4 being an option that is not possible here. Okay, so in between 28 and 32, the thing is I would probably go for the one which is closest in mass to the nitrogen, because nitrogen is 34. If I go for the lighter one, this will still diffuse into the chamber here through the porous port, this will still diffuse faster than this, and therefore this 32 is probably the best answer. Being the heaviest, it will diffuse the slowest into the porous port, and once it diffuses into the porous port from the higher concentration outside into the low concentration inside, the 32 mass is still lower than 34, and that means previously you have something of mass 34, now you have something of mass 32, and therefore what happened is that they diffuse at almost similar rate, but this one is lighter than this, and therefore this pressure will exert downward more compared to them for nitrogen. That's why it goes in this direction is the question required. So I will go for oxygen being the best option here. Okay, so these kind of questions are very well, a bit tricky, and they are often popular, as I mentioned, in Cambridge exams, yeah, or whatever other 14 to 16 years old chemistry exams that you're doing. Okay, so that's all for me, and I'll see you in the next video.